Let's recap. We were told the concentration and the volume of the hydrochloric acid used, from which we calculated the number of moles of HCl present at the start. This HCl was reacted with 5 grams of seashell. Some of this seashell is calcium carbonate, and some of it is impurity. And we're trying to find out what proportion is calcium carbonate. Only the calcium carbonate component will react with the HCl. So if we can find out how much HCl reacted, then we can calculate how much pure calcium carbonate there is in the shells. The first step in finding this out is to calculate how much HCl did not react. In other words, was in excess. We're told that this excess HCl is titrated against sodium hydroxide of a certain concentration, and we're told the volume needed to neutralize this HCl. From this information, we know the number of moles of sodium hydroxide needed to neutralize this HCl. And since we know the reaction ratio between sodium hydroxide and HCl, we can deduce the amount of HCl which reacted with the NaOH. So we now know the amount of HCl which was in excess in the shell reaction. We use this information together with the known initial amount of HCl to calculate the amount of HCl which reacted with the shell. We know that this HCl only reacted with the pure calcium carbonate part of the shell, and we know the ratio in which HCl and CaCO3 react. From this, we can calculate what mass of calcium carbonate must have reacted in this situation, and therefore how much calcium carbonate was in the seashell. We were given the mass of the whole shell sample in the question, so from all of this, we can then calculate the percentage calcium carbonate purity of the shell sample.